In the last video, we covered from comments to statements in C#. In this video, we'll talk about functions and methods. As I mentioned before, functions exist by themselves, while methods are basically functions attached to a class or object. Like Java, C# mostly has methods, but it also has functions in a couple of places. In this video, we'll talk about local functions, and later we'll introduce anonymous functions when we talk about delegates. Starting with a regular method. This is how we can define a method, and this is how we can call the method. They are exactly like methods in Java. Let's do a quick example and see how it works. So I have my program class, my main method here, and let's create a new class called example. And inside this class, let's create a method. We'll call it add, which adds two integers together. Very simple, and it returns a sum. And inside the main method, we'll first create an object, and then we can call the method of this object. And let's simply call example.add, and let's add 10 and 20 together. Close the parentheses, and we'll run it. And it prints out 30 as we would expect. We'll talk more about class later, but for now you can see that it basically works the same as in Java. We define a class, we create an object, and then we call the method of the object. If there's only one statement in a method, we can simplify the method by using the lambda operator, which looks like an arrow. If you know JavaScript, you know that this is basically the arrow function in JavaScript. When we do this, we can omit the braces and the return keyword. For example, we can create another method, and this time we'll call it add2. Same thing as before, but this time we simply say arrow and then x plus y. So in this case, we can omit the braces, we can omit the return keyword, and it's still returning the sum of these two values. And if we change this to add2 and run it, still the same thing. So this is called an expression-bodied method. And the same thing applies to constructors and the property getters and setters as well. We'll talk more about the lambda operator and lambda expression later when we talk about delegates. For now, just think of it as a shorthand way to write single-line methods. In C#, we can create functions inside functions or methods, like this one. These are called local functions, and they can access the parameters and the local variables of the parent. For example, in this example, the local function add can access the parameters x and y of the parent function or the outer function. And the parent function simply calls the local function and return its result. Again, if you know JavaScript, you'll probably saw functions inside functions like this a lot. This is actually one of the things I like about C#. The language just keeps evolving. If they see nice features in other languages like in JavaScript, they just add them to C#. You might be wondering, why do we need local functions in the first place? In the previous example, we could simply do return x plus y, without using the local function, and it will work perfectly fine. Hopefully, this example would convince you that it's worthwhile to have local functions in certain situations. For example, suppose we want to process a number of lines, and if a line is valid, we will do something with it. Suppose the logic to check if a line is valid is kind of complex, so it would make sense to encapsulate that logic inside a local function. And we can then simply call that function for each line to check if the line is valid. Now, moving on to C# method parameters. In C#, we can have default values for parameters. When we call a method, we can omit the arguments if they have default values. So these arguments are called optional arguments. In this example, for example, the second parameter y has a default value 10, and because of that, when we call the method, we can omit it and simply specify the argument for the parameter x. And in this case, y becomes optional, and when we call the method like this, y will take on the default value of 10. This is quite convenient for lots of situations. Just remember that the parameters with default values like this should be at the end of the parameter list, after those required parameters. So what if we have a method with several parameters with default values? Like in this example, if we want to call the method with x being 10 and y being 20, we can simply call the method like this because x and y are the first two parameters. However, what if we want to call the method with y being 20 and z being 30, but leave x to the default value of 1? Well, we cannot call it like this because we cannot skip a parameter. However, in C# there is something called named arguments that let us to specify which value is for which parameter, like this. And any parameter that are not specified will have their default values. In addition to optional arguments and named arguments, C# also lets us change the default parameter parsing behavior. Recall that by default, value types are passed by value and the reference types are passed by reference. But what if we want to pass value types by reference? Well, we can actually do that using the ref parameter modifier. For example, suppose we want to use a method to switch the values of two variables. For example, let's create a method called switch. It doesn't return any value. Instead, it takes in two values and it will try to switch those two values. So x will have y's value and y will have x's value. And the way we do that is simple. We put x into a temporary variable and then we assign y to x and then we assign that temporary variable to y. And that's supposed to do the trick. Well, let's see. So suppose I have x is 10 and y is 20 here. And let's say we call switch example switch x and y. And then we try to print out the values of x and y, we'll say x is x and y is y. Remember the interpolated string. So if we run this, we can see that x is still 10 and y is still 20. They are not switched. The reason is simple because both x and y are integers. They are value types. So when we pass x and y into the switch method, we simply pass their value. In other words, the runtime will make copies of them, and we simply switch their copies, but we didn't switch the real thing. Now, with the ref parameter modifier, we can change the default parameter passing behavior from pass by value to pass by reference. So we can do something like this. And when we call the method, we'll also put ref and ref here. And if we run this again, now we can see that x becomes 20 and y becomes 10. They are actually switched. And this, of course, is because we are passing those two arguments by reference instead of making copies of them. There's another parameter modifier in C# called out. It's similar to ref in the sense that it would pass value types by reference, and in addition to that, it requires that a value be assigned to the parameter inside the method. In other words, a parameter labeled as out is actually a variable used to get a value out of a method. As you can probably guess, this is usually useful when a method needs to return more than one value. A good example of the out modifier is the try_pass method in the int class. So let's take a look. So this method tries to parse a string into an integer. But because not all strings can be parsed into integers, for example, we cannot pass hello into an integer, this method needs to return two values. One Boolean value to indicate whether parsing is successful or not, and if parsing is successful, it also needs to return the passed integer. As we can see here, it uses the return value to indicate whether parsing is successful and use a out parameter to return the passed integer. So if we want to try it, it will look something like this. We'll say result is int try parse, and we need to have a value, and the first parameter is the string, so let's say it's 100, and the second parameter is out value. So if parsing is successful, value will have 100 and the result will have true. So let's try that, and we'll say result is result and value is value. Okay, so if we run this, we can see that it says result is true, meaning parsing is successful, and the value is indeed 100. So what if we have a string that is not an integer, we'll get result is false, telling us that the string is not an integer. Notice that value still has a value because int is a value type, so it cannot be null. No matter what, it will have a value, and by default, it will be 0. So if you simply look at the parsed result, you actually cannot tell whether the input is an invalid string or the input is actually a string with a letter 0 in the string. But by examining the result, we can know. We can tell that the original string is not a string for an integer. So this is how we can use the out parameter modifier. So as you can probably guess, if we can designate a parameter to be an out parameter, we can also designate a parameter to be an in parameter. The in modifier does two things. First, again, it makes both value types and reference types parse by reference. And second, it prevents the method from changing the parameter value, basically making it read-only. In other words, the in parameter basically says that the parameter is only for putting value into a method, and that value should not be changed. The last parameter modifier is params. This allows us to pass multiple arguments into a single array parameter. Only one parameter can be labeled with params, and the parameter must be the last in the parameter list. Let's see an example. So let's create another add method. And this time we're going to take an array of values and we're going to add them up and return the sum. So we'll use the for each loop. We'll say for each value in values, and we'll do a sum plus value, and in the end we'll return the sum. Something like this. Now, if we just declare the method like this, then if we try to call the method, we have to pass an array to it. However, we can say params, and by having that modifier, we can then pass a bunch of individual values to it. So let's say we add 3, and we'll do 10, 20, 30, 40, something like that. Notice that we're passing 4 individual arguments to this method, and this is not an array. There are 4 individual integer values. However, because of the parameter modifier, the compiler will collect all this and put them into an array and then pass it to the method. So in the end, it works as we would expect. It adds up 10, 20, 30, 40, and the result is 100. So this is a cool trick if you want to create a method that can take any number of arguments and then just treat all those as an array of values. Okay, so we'll stop here. Methods are covered in chapter 4 of the Pro C# 9 book. Yes, Pro C# 9, not 7. Please have a look at it when you have time. Thanks, and see you in the next video.